Alrighty, moving along with 10-3, so we're going to actually have operations with all these radical things. We're going to add a few new rules to it as well. First off, like radicals. Those are radicals when simplified are the same radicand. So I can have 2 square roots of 3 is a like with negative 10 square roots of 3. So the idea is they have the exact same radicand. Or I could say 3 square roots of x is like 20 or negative 21 square roots of x. Now when they're like, the great thing is we're able to add or subtract them together. You don't just have to multiply. Just to make sure we understand the idea, unlike radicals they have different radicands, so don't have the same one. So 2 square roots of 3 is not like 3 square roots of 2. You cannot add them. You could multiply these two, but you would not be able to add them. So these would be unlike. Or 3 square roots of x and 3 square roots of 4x. Right? It has to be exactly the same under the radical. And again, we'll be able to add and subtract those later. Conjugates, they are when we have, so first off, it's the sum and difference of the same term. So notice a squared to b plus c squared to d. That's a conjugate. Notice the ab, cd, cd, one's addition, one's subtraction. When we put them together, it's called a conjugate. So conjugates down here are the sum and difference of the same two terms. For example, square root of 7 plus square root of 3, square root of 7 minus square root of 3. This and this are conjugates of each other. The really cool thing about them is that when you multiply them, like foiling, notice I take this one, put it in parentheses, take this one and put it in parentheses. If I FOIL it, and we'll write the whole thing out here for you, so that's going to be square root of 7 squared, right, plus 3 square roots of 7, right, that's those two multiplied, minus 3 square roots of 7, that's these two multiplied. I'm sorry, square root of 3 and square root of 7. And then at the end, we would end up with minus square root of 3 squared. And in the middle here, notice that these two, right, are exactly the same, so they're deleted. So you get square root of 7 squared, which is 7, minus the square root of 3 squared, which is 3. So 7 minus 3 is 4. So that's what conjugates do for you. And just like we used a well-chosen 1 when we went through and rationalized the denominator in the last section, we're going to use conjugates to help us get rid of radicals in the denominator of an expression. For instance, just going to throw a little more at you here. If I gave you 2 over the square root of 7 minus the square root of 3, you could multiply that by the square root of 7 minus the square root of 3 over the square root of 7 minus the square root of 3. Notice I have another well-chosen 1. Sorry, plus rather, because we're looking for conjugates. That's going to help us get rid of the radicals in the denominator. And we'll work more on that later, but that's the whole point of them. Now this slide is designed to remind us of some rules here. If I have the same, right, the same expression here, so a 2 or a 3 or a 4, right, as the root expression, I'm allowed to multiply those things inside. So, and again, likewise, I'm allowed to divide them or combine them as a fraction. So if I had the square root of 4 times the square root of 7, you know what, the 4 is not really the best choice because that one's clearly has, there we go, square root of 3 times the square root of 7, that's the square root of 21. Likewise, if I had the square root of 10 over the square root of 3, that's like having the square root of 10 over 3. And again, this is the reverse of a rule we had in the last section anyway, nothing new here.